All right, here we're doing the list processing algorithm. And in essence, what we're going to do is follow the order that they give us, whatever list they give us. And if something requires a prerequisite, for example, T10 requires 6, 7, 8, and 9 be completed before we can do that. So there's a prerequisite there and it's not ready. So we go and we look at T9. T9 has a prerequisite, that's not ready. And we keep going down the line until we have one that's ready. Okay? So what I'm going to do is go ahead and grab a highlighter for the different tasks. And we're looking to look and see which one is ready. So we're going from T10, that one's not ready because we have a prerequisite. T9, not ready. T8, not ready. T7, not ready. T6, not ready. T5 is ready. So what I can do is I can mark off T5 off of my list, and then I can go ahead and do T5, and it's a 4-hour job. So I'm going to give that to the first person. Okay, so T5. All right, T5 is completed. All the other ones still take prerequisites more than just 5, so I'm just going to keep going down. The next one is T4. The next one is T4. So T4 is 2 hours. So I'm going to give that to Kyle. So that's T4, and T4 is completed. T4 and T5. Okay. So T4. T10 I can't do. T9, T8, T7, T6, T5, T4, T3. So T3 is my next one. T3 is 4 hours. 1, 2, 3, 4. And that's going to be T3. So T3 is completed. Now I go back to the beginning. T10 I can't do. T3, T4, and T5 are needed to do task 9. And task 9 is 2 hours. But my 3 and my 4 are not ready yet. So I really only need one that's ready for T4. I can't do that. So my next one has to be T1. That's the next one. Because none of these aren't ready. These aren't ready. These aren't ready. So I need to do this one. All right. So I'm going to go down to, let's grab a different color. And I'm going to do T1. T1. T1 is 4 hours. So 1, 2, 3, 4. So T1. All right. So T3 and T1. All right, I'm going to go back to the beginning. And T10, I still cannot do. T9, T3, 4, and 5. I can do T9. So I'm going to go ahead and do T9. 3, 4, and 5. 3, 4, and 5. So I can do T9. There we go. So that's done. Can I do T8, T2, and T5? I don't have T2. So I can't do that one. T7, T2, and T3. Nope, can't do that one. T6, 2, 3, and 4. Nope, I don't have 2. So it looks like I need to get 2 completed. So 2 has to happen after 1. So I'm going to go ahead and put T2 right here. Okay, and that is completed. And what is my next available? T10 I cannot do. 6, 7, 8, 9 have to be completed. T9, T2, and T5. T2 and T5 can happen T2 and T5 can happen after T2 is completed. So I could put that right here. T2 and T5, T8 can go right here. Okay. So T8's completed. T7, T2, and T3. So T7, I can do T7. So we'll make T7, T2, and T3. And it's 1 hour. So T7, T6, T6. So T7 is completed. T6, 2, 3, and 4. 2, 3, and 4. So I can put 2, 3, and 4. I can put that here, and it's a 1 hour. So T6 to T2, 3, and 4. Okay. And then the only thing left to do is going to be, looks like so we have T1, 2, 3, 4, 5, 6, 7, 8, 9. And so we just need T10. So we can put T10 any one of these areas. So T10 is 2 hours. So I've got T10. Okay. Now, is there a more efficient way to do it? If I was doing this outside of the list processing algorithm, and we look and see, and this one takes 11 hours, right? I probably, because T1 is a critical path, I probably would have started that 2 hours earlier, and then that would bring T2 down and kind of shore up some of those other ones. But we were using the list algorithm, which means that I'm doing it in order of what it tells me to do it in. So we got that, and we're good to go. All right, there's clearly at least one ordering of the task which produces a schedule that completes the job in the least amount of time. It's not easy to find it, though. One approach is to use that order requirement digraph. In this digraph, a high-weighted directed path adds up to weights of all the edges in the path, indicates a sequence of tasks that will take a long time to complete. Each task in the path needing to wait for all the other tasks before it to be completed before it can be assigned to a person. So it makes sense to start the first task in such a path as soon as possible. So up here where we were talking about one of those critical paths being T1, and if we could start that T1 earlier, but it was at the end of our list, so that's why we didn't. All right, so find a critical path P in the modified order requirement digraph. Place the first task in the path P at the next place on the list. Delete this vertex from the graph to form a modified order requirement digraph. If any tasks have still to be placed on the list, then return to step 1, but now use the modified order requirement digraph you just found. You'll have one less vertex each time you return to step 1. All right, so let's look at what our critical paths are. We have one that goes from here to here, and then to here, and then to here. All right, so that's one. We have another critical path here. So we got one that goes there and there. Now this one also goes to all of these, right? So those would be critical paths as well. So those are our main critical paths that we have. So find an ordering of the task by applying the critical path algorithm. All right. I would go ahead and do T1, and then T5 is another one of our critical paths. So I'm going to get rid of those two. The next one that takes a whole lot of time, that's a prerequisite for other ones, is T4, because this 2, right, this requires this one to start processing before it can hit all these. So it's okay for me to go ahead and start. We're kind of going from here into that direction. So I'm going to go ahead and hit T3 next, because T3 is a smaller path. 4 plus 1 is 5 plus 2 is 7. Yeah, and then T4 is a 2-hour task. So I would put that last, okay? And then what we want to do is make sure we get T2 completed. So T2 comes next. And then I could do 6, 7, 8, and 9 in any order. I'm probably going to do 9 because it has a higher weight. So T9. Okay, because notice these are all kind of in the same timeline. My next one would be T6, T7, and T8. And then, of course, T10. Now, these three here, 6, 7, and 8, 6, 7, and 8 are all part of that first critical path. So you could switch up the order of those. It's not going to make that big of a difference. Okay, so that's that is our path. So we're going to go ahead and take a picture of this, and then we'll go ahead and add it to our next task on the very next page.